6,298 confirmed exoplanets. That's the number reported by NASA Exoplanet Archive by the time of writing this script. The closest one is just over 4 light years away, though it orbits a red dwarf, the type of stars that are long-lived but typically very active. So where is the nearest Earth-like planet orbiting the habitable zone of a similar star to our Sun? About 1,810 light-years away, in the constellation of Cygnus, there is a planet called Kepler-452b, the first confirmed planet similar in the size of the Earth that is orbiting a star similar to our Sun. Let's start with the star. Kepler-452 is a G2 type star, a yellow dwarf with a surface temperature of about 5,800 kelvins, the same type as our Sun. It is about 1.5 billion years older than our Sun and about 10% larger. By the way, it is precisely by observing stars like this that we know how our Sun's evolutionary process will unfold in the future. Now let's talk about the planet. It orbits at a distance of 1.05 astronomical units from its star, almost identical to Earth-Sun distance. A year here lasts about 385 days, and the planet receives a comparable amount of energy from its star as Earth does from the Sun. It also lies within the habitable zone, where liquid water could exist. But of course there are also some differences and uncertainties. Its radius is about 1.6 times that of Earth, and the probability that it is a rocky planet is estimated at 50 to 60%. If it is a rocky planet, surface gravity would be nearly twice that of Earth. This exoplanet currently sits right at the inner edge of the habitable zone, close to the threshold known as the moist greenhouse effect. This is a point between which water vapor in the atmosphere triggers a self-reinforcing feedback loop. More water vapor strengthens the greenhouse effect, temperature rises, which causes even more evaporation. Research suggests that the planet likely spent its first 5 billion years in the comfortable Earth-like conditions, but now as its star grows brighter, it's approaching this threshold and may even be starting to cross it. We can't know for certain since the effects depends on the atmosphere, the amount of water and the cloud behavior, which are currently unknown to our knowledge. This makes it even more fascinating because if it turns out that it's a rocky planet, more research could give us a better understanding of our own Earth's future fate. Could life arise on such a planet? Surprisingly, its mass and size aren't necessarily deadly for life, especially for microorganisms or aquatic life. Land-based life could exist too, but they would likely need to evolve a stronger skeleton and a more efficient circulation system.